Welcome and hello. This is a video exercise in HEC RAS, and in this exercise, I'm going to be demonstrating riverbed armoring. So what that means is if you have sediment in a river that's eroding, then we can put a second larger gradation of layer on top of that native layer, and that will prevent the erosion. So that's what's meant by armoring. Let's go ahead and get started. I've got HEC RAS open up here. I'm going to just start from the very beginning. So File, New Project, and then navigate to where you want this project to be saved to. All right, and then in the title text box, go ahead and give your project a title. I'll say Exercise 29 from me, and then click OK. All right, click OK here. All right, so first thing I want to do is sketch out my geometry file. So I'm going to come down, go Edit, Geometry Data, if you don't already have this lower window opened up. And then I'll click on River Reach, then single left click at the upstream end of the reach. So I'll just go ahead and add some more clicks with single left click and then a double left click at the bottom of the reach. And then give the river a name, give the reach a name, and we're good to go. All right, next up is cross sections. So I'm going to go Options, Add a Cross Section. I'm going to start this at River Station 0 at the bottom of the reach. And then I can type in or paste in my cross section data. So this is what it is right here. We'll have a preview of that in just a moment. All right, so the downstream distance is 0 because this is at River Station 0. Okay, right there is my Manning's end values. And then the left and right bank station is going to be 60 and 150. I'm just looking at the data here. And then apply. Here is my cross section at the bottom of the reach. All right, so I'm going to go ahead and add another cross section at the top of the reach. It's going to be 2,000 feet upstream. So I'm going to just copy and then type in 2,000 here, copy that, and then also put 2,000 here for the downstream reach length. The other thing I need to do is add some elevation. So let's go Option, Adjust Elevation. I'm going to make it a 1% slope. So that would be 20 feet. And then, yeah, okay, so apply. And then I'll close that. All right, got my cross sections there. I want to add some intermediate cross sections. So I'm going to go up to Tools, Interpolate, within the reach. It's going to be within this reach for all cross sections. And let's just say every 100 feet. So interpolate and close. All right, these are my interpolated cross sections right here. There's a little asterisk by the river station numbers, just so you know it's interpolated. All right, so that's good. I'm going to go ahead and save this geometry file. So I'm going to go File, Save Geometry Data. I'm going to call this 1% slope as the name of my geometry file. Okay. Next, let's go ahead and define our flow data. So this is going to be a sediment related simulation. So I'm going to go with quasi-steady flow data, quasi-unsteady data. The downstream boundary condition will be normal depth. I'm going to type in the channel slope and then click OK. And then for the upstream cross section, the boundary condition will be a flow series. That's my only option. And then we're going to use enter table data, use simulation time, and then enter the actual data right here for flow duration, computation, increment, and flow rate. Okay, so I've got some data I copied onto my clipboard from Excel. I'm just going to come down here and paste. All right, and so I have 53 records here, and it's going to be a 1 month simulation, so I really only need 31 days for January, and it's a constant 10 CFS. So I'm going to see if 10 CFS is enough to erode my entire river reach, but right now let's just go ahead and save it. So I'll click OK, File, Save. I'm going to call the file 10 CFS, and then click OK. Also, what I need to do is to set the temperature. And let's just go with the constant 50 degrees. For the entire month, I'll just add some huge number here. So I guess I could have done the same thing with flow rate, but it's all right. All right, so that is it for the quasi-unsteady data. I'll go ahead and save that and close it. Next, I need to define the sediment data. So I'm going to come up to Edit, Sediment Data. All right, first things first, let's go ahead and define the depth of erodible material. That's going to be 5 feet for the entire reach. So I'll copy that down. I already have the reach and the river selected because it's the only reach and river in my geometry file. I'm also going to just use the default values here for transport function, sorting method, and fall velocity method. And then for the left and right station of area that can be eroded, I'm just going to go ahead and click the button to use the bank for the movable bed. And then the bed gradation, that's the last thing I need to do here for this first tab. And I'm going to define that gradation. So I'll click on New Gradation. I'm going to call it Native Only. And then for percent finer, I'm going to paste in these values right here. So you can see it's 25% coarse silt, and then another 25% very fine sand, and then another 30% fine sand. So it's mostly sandy. Okay, so I'm going to click OK. And then I need to define the boundary conditions as well. For this example, I'm just going to use clear water. So click on the clear water, no sediment. I'm more interested in erosion than deposition, so I didn't want to add or introduce more sediment into the mix if not necessary. Okay. All right, so I'm going to go File, Save Sediment Data. I'm going to call this native only, for only the native soil sample. And then I'm going to go File and Exit. All right, let's go ahead and create the plan, run the plan, and then look at some results. So I'm going to go up to the, let's see, Run Quasi-Unsteady Analysis. We already have everything loaded in we want here, our one and only geometry file, our flow file, and then our sediment data. Next, I need to specify the start and end date time. So I'm going to just use the month of January, starting at the beginning of the month, and then just go all month long. So it'll end at February 1st. For the plan name, I'm going to go File, Save. I'm going to use 10 underscore native only. So that represents the flow rate of 10 CFS, which is right here. And the native only is the sediment data. I don't plan to change the geometry file or the slope or anything. So I'm not going to mention that in my plan data. All right, so click OK. I'll use the same name here for the short ID. And I think we're good there. Let's go ahead and compute and see what happens. Okay, so I forgot to make that assignment of sediment. I defined the sediment, but I didn't actually assign it to the cross sections. I think that's what that meant. Yep, that's right here. Okay, so native only. Let me just copy that all the way over. File, save sediment data. And I think this should work now. Let's give it a try again. So let's see, sediment transport analysis and compute. Okay, so it ran. That looks good. What I'm seeing here in the results is that we have no sediment coming into the model during the simulation, and that makes sense because that upstream boundary condition was clear water. And then I do have a lot of mass and volume leaving the river reach during that 31-day simulation. As you can see, 4,900 tons and it's like 121,000 cubic feet. All right, let's go ahead and actually look at the results. So view, I know there is sediment output data, but I wanted to actually just look at the cross section in like the original classic hydraulic water surface profile output here. Okay, interesting. So I'm going to actually just animate this and then just play it through. Okay, so you can see the erosion taking place over the course of the month. So that's the end of the month right there. It looks like most of the erosion is taking place up at the top of the reach, but slowly eroding further downstream. So I can look at that same erosion in the actual sediment option output viewer. What I would do is I'd go to, let's click on invert elevation. And actually, I want to see original invert or mass invert or maximum invert. Let me rerun the simulation real quick. For the output options, change the output to level 6. That's going to give me more data because I was expecting to see some other variables in that results window. So let's see if this works. Let me save it real quick and then compute again. Okay, so that computed. Let's go ahead and see if I can find the results I'm looking for this time here. And I would like to make this window taller so I could see more than just 7 or 8 variables at the same time. But okay, invert, not invert change max. I want invert max and invert elevation. And then for the mode, I'm going to change this to profile. And then I'm going to change the animation speed to the fastest and click the play button. So there is an animation tool here. What does work is when I just use the scroll bar. So there we go. That was the same animation we saw earlier, where the top half of the reach is eroding with less and less erosion further downstream. Okay, so before we add armoring, what I would like to do is increase the flow rate, run the same simulation, and then observe additional erosion because I wanted the whole reach to erode completely, but that didn't happen. So let's go ahead and go to our edit, quasi-unsteady flow. What I'm going to do here is go File, Save As. So this is going to be a new flow file. I'm just going to add a 0 here because we're going to go with 100 CFS. Okay. Everything else is going to be the same, but for the flow series, this flow right here is going to be 100 instead of just 10. So I think a quick way to do that is to just delete all these records. Okay, I don't need quite that many, but I'll just type in 100 here and then interpolate and then click OK. All right, file, save. Everything else is the same. So yeah, I have 100 CFS now selected. Perfect. Now I want to save this plan. This is going to still be native only. There's no armoring, but 100 CFS. Okay. And the short ID and OK and run. All right. So that ran again. We have, I think, 3 times as much sediment removal as in terms of mass. And the volume looks to be almost 3 times as much as well. All right. So that leads me to believe that the entire reach has been eroded, that 5 feet of depth that we defined. Let's go ahead and take a look at the cross-section data again. So, yep, this is the last time step. It looks like it's all completely eroded. Animate and then play. Okay, so it all eroded within the first 10 days of the month. Basically, 1/3 of the way through this simulation, it had completely eroded. Right about there, and that's January 13th. Okay, so it took almost half the month, but let's go ahead and look at the same results here. If I go to sediment output, okay, so where are we? We want invert elevation and invert max, and then I'm going to change the mode to profile again. And then I'm just going to scroll across. Yep. Okay. All right. Very cool. I can also compare plans. So if I go options, plans, I can toggle on the 10 CFS plan, click OK. Okay. So when I do that, it clears out my variables, unfortunately, but I can just add them back in. So invert max, invert elevation. And then if I change this to, oh, okay, profile, it's already there. All right, let me just go ahead and manually click. Let me change the colors here. Okay, so it looks like green is our 100 CFS and then purple is the 10 CFS. Okay, it looks like it's changing colors every time step. Let me just change it back to the original colors. So we can see that the 100 CFS is eroding much faster, and then the 10 CFS is eroding much slower. So we're about 1/3 of the way through the simulation, maybe halfway done right now. The 100 CFS is completely eroded. The 10 CFS is still almost eroded at the top of the reach, but we know that we've already seen these results. It's not going to erode more than just this right here. So if I toggle on the colors, the cyan or this light blue here is the erosion of the final invert after 1 month of 100 CFS flow. The light green is the final invert of the river channel after a month of 10 CFS flow. All right, let's go ahead and add some armoring now. That's the whole purpose of this exercise, is to add a larger grain size distribution sediment on top of the original riverbed. So what that looks like is I'm going to go to the sediment data. Now, first thing I'm going to do is just create a new sediment file with armoring. So this one says native only. So I'm going to say file, save sediment data as native with armoring, and then click OK. What I want to do here for the gradation is create a new gradation. So already I have native only. Now I want to go new, native with armor. Okay. And then for the gradation here, I'm just going to paste in what I have prepared. It's going to be 50% coarse gravel and then another 50% very coarse gravel. So, of course, we could make this different, but this is what I'm going with. If you wanted to convert that over, it'd just be 50%. Okay, I don't know why it does that. Okay, that's what I want right there. Okay, so let's go ahead and click OK. And then everything else is going to be the same. File, save. Oh, what I need to do is actually apply that gradation, not forget to actually assign it like I did here. So this is all going to stay the same. This is the main bed gradation. There's an option here to apply the armoring. If I go up to options and then bed mixing options. Now what I want to do here is click this checkbox here that says cover/active layer gradations. Click this checkbox, and now I want to select the native with armor right here. I guess this gradation is the armor itself. I don't need to say native. So let me go back and rename that gradation. So here's native only. I could have just called this native. In fact, let's do that as well. So here's the rename button. This is native. And then let me rename this. This is going to be called armor. Okay, so that's armor now. I'll click OK. So this needs to be called native. And then let's copy that everywhere. Okay, file, save. And now let's go to those options, which is bed mixing options. And then this should be armor. Let me copy that down. So I'm using the armor for all the river cross sections in the reach, river A, reach 1, And then the thickness, this is something I don't have a lot of experience with. Let's just say 1 foot and see what happens. I think that should be good. All right, so click OK, File, and then Save. So this sediment file is called Native with Armoring. That's what I want. And then let's create a new plan for either the 10 CFS or 100 CFS with the armoring. To do that, I'll go up to Run, Quasi-Unsteady Analysis for sediment. And what we have here is 1% slope geometry, 100 CFS, flow rate, and then the sediment data we were just editing, this native with armoring. Perfect. So I just want to save this as a new plan now. 100 native with armoring. We just call it armor. Okay. So copy that. Okay. Same thing for the short ID and compute. Okay. So it looks like we have much less sediment loss. It's only 32 tons. So over the course of a month, that's really nothing. 703 cubic feet of material loss over the course of a month. Again, that's pretty much nothing. So the armoring worked. We can go ahead and view those results. Let's go ahead and look at this cross section. Yeah, there's nothing lost basically. Boom. Very nice. So a few of the things we could do is either reduce the depth of that armoring. For instance, we know what our gradation is, and we need to minimize the amount of armoring required. Or another option is to change the gradation, keep the armoring at 1 foot. So let's go ahead and do the first option. Let's just go ahead and reduce the depth of the armoring. Now what I'm going to do is just use the same sediment file here. I'm going to go back to Options, Bed Mixing Options, and then I'll say the armoring is 0.5 feet, so just 6 inches. Click OK, File, Save, Close. I'm going to run the exact same plan we had before, so compute. Okay, it looks like, again, I don't need to look at the results. There's only 30 tons of material loss. That's nothing. Let's go ahead and just change it to 1/4 of a foot. So that's 3 inches or 0.25 feet sediment. And then options, bed mixing options, 0.25 feet. Then we'll save that, close, and then run. Okay, so we had 694 tons of material lost for that entire month, but it was definitely more than 1 foot and also 6 inches of armoring. So I'll close that. I'll go ahead and look at the results by going View, Sediment Output, and then for the variable, I'm going to go invert max to represent the original invert, and then invert elevation, change this to profile. I could have saved a favorite. And then let's go ahead and look at that change in, okay, so over the course of the month, it looks like it was eroding. This is the last time step right here at the end of the month, but just barely. It looks like it's eroding about 3 feet here and then 0 feet here. And of course, over time, it would erode a lot more, but certainly the armoring is providing much protection to the native bed gradation. All right, well, that was it for this exercise. What we did was set up a river reach, and then we added sediment data for both native soil and the riverbed, ran the simulation, observed a lot of erosion, and then added armoring on top of that, ran the simulation again, and noticed much less erosion.